right, welcome back to another video in our series, my series, part two. Last video, we went over incident response tools. In this video, we're going to go over cryptographic basic concepts. And the first exercise, we're going to be implementing cryptography, right? So cryptography can be challenging, to be very honest, but I'm going to lean all the way into it as much as humanly possible to make sure that I understand it to the point I grind it down to where it's the simplest thing as the alphabet to me, right? So cryptographic tools are just generally used to generate and confirm the integrity of information or data and be used to confidentially to protect from the unauthorized viewing of materials, right? So this greatly assists with the security of information that we're receiving from the source location. Further with hashing, we can confirm, for example, a program that's been downloaded but has not been modified in some manner by checking the hash value produced by the author of the file, right? Just sending it. So what we're first going to do is encrypt some data using Cryptodemo. So even though there are various tools, right, to actually encrypt information, Cryptodemo is actually a small tool that that can actually help us encrypt and hash information. And it only contains two tabs, so it's pretty simple. So one is for hashing, right? And one is for encryption. Now on the encryption tab, right, we can choose different algorithms, right? We can choose different algorithms here. We can choose and encrypt the information, by the way, but on the hashing tab, we can actually generate different hashes, which we'll show in a second. Actually done in another video. I've actually done this before. But yeah, you can generate hashes, files, text values, and text strings also. And we're actually going to encrypt some data using Cryptodemo. So what we're going to start with now is just the 3DES is good. And now we're just going to to see the output and recognize what such an output generates in terms of values. So we're just going to stick with the default here, the triple DES. I'm just going to type here, right? And then I'm just going to type in the data field. Welcome. There we go. All right, perfect. So now I'm just going to encrypt it to see the result of the encrypted data, right? And we'll see it here in the encrypted data field. So this is what's called ciphertext, right? It's displayed in this box, right? And the text is going to be different from the strings that we entered because it should be unreadable, which makes it so powerful, right, as far as encryption. And we can press the encrypt button as many times as we like, and we'll see different results of the output data. And this is one of the most important concepts, conceptions behind encrypting text, right? So now we can actually decrypt data using Cryptodemo as well. So now that we've encrypted, a piece of data, I keep doing that. It's just so cool to me. Now, which was in the form of a text string, of course, we can now decrypt it from data. So by decrypting the encrypted content, we're going to verify this the same as it is from the source data, right? Which was encrypted. So actually, let's we're going to stay right here. So actually, let's decrypt. What happens, right? So actually, let me. Okay, let's go. Just freezing that. Doing that. Delete this. Boom. This is amazing. We have the same exact original text that's decrypted from the data. And we can try also with the other types of algorithms, right? The encryption. Encrypt. Yeah, we can delete that. Decrypt. Same concept. Same concept. Right? Same concept. So this is awesome, right? This is awesome. And actually, if I delete the last character from the encrypted data and I click decrypt, it's going to completely throw off the data as far as the text, right? So the original value, right, is just no longer generated, right? So it's just gives us an error message unexpected end of data, blah, 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 blah. So now we can actually take a look at key values, right? So in general, mixing up as many as possible as far as what belongs pretty much, it just produces a strong key to encrypt or hash again. So we use these options presented by random key and time key. With the random key option, it generates a base 64 random key, right? So as the name suggests, when you generate a time key, it uses time as the key, right? So what we just did was we had input our string to generate an encryption key. However, this is a poorly secured key. So better option would be to generate a random or time value key, which is a lot more secure. So we're just going to generate some key values, right? All right, so to do this, actually take this and delete it, and actually delete this too. But I want to make sure I keep this in the box, right? So now I'm just going to click random key so I can see what it looks like. Now it's going to be random, so my key is gonna not gonna be what you expect, right? It's just keep going, even though you have just text in there. So now we see the random key appears in the place of the text that I originally have to practice that, right? So now if I hit encrypt, right, to see the ciphertext generated using this type of key, now the random key usually, if I had kept the data here, it was still encrypted. So yeah, perfect. So we have a double layer here. So we have a random key encrypt. So we have a encryption algorithm, right? Then we have a random key. We have the actual data that we want or we can decipher, right? That we want to look at, and then we have the encrypted data. It's just so amazing, right? Computers are amazing. They're awesome. So I'm actually going to delete the encrypted data again, right? And then I'm just going to click the time key and then encrypt. And then I get something else, right? So I see the values that are generated here. So once more, we can see there's another output that differs from the first result, right? So actually, we've done enough in the encryption task. So let's take a look at hash. And what hashing is a value that's used to map uh, data of any size, right? And provide a method for verifying the integrity and authenticity of the data and the authors of it. So the crypto demo application can also create these hashes. So now we're going to use the same tool that's used for encryption for hashes as well. So let's actually make sure it's set to, yeah, MD5 is all right. So let's do this. Perfect, and then get hash. Similar concept to encryption, right? But once again, if we click on it, we'll get the same value. Unlike encryption, a hash always remains static and does not change. So we can actually change the hash algorithm. So I can change it to 1, right? That's how I get a different result. In G4, get hash, perfect. Right, so we can see the different result from the different algorithms, right, that we have that generates a different hash. So now what we're going to do is actually use another version of hash help. So it's the beginning of calculator, so first hash. The different algorithms, right, they generate different hashes as we've seen here, right? And what hash help does is help us generate different hashes from using 13 different algorithms, not just a few here, but 13 with the click of a button. So we can actually look at different hashes generated from algorithms and perform a direct comparison, right? So Hashcat can actually compute messages, digest, checksums, HMAX for different inputs, and a few other things, right? So we can actually use it here. Perfect. Perfect. I believe I used this in another video, if I remember correctly. So I'm going to change this to a text string, and of course, we're going to put some data here so we can have some data to apply the hash calc to. So nonetheless, still, it's going to make sure all the checkboxes, all the boxes are ticked to confirm for all the hashing algorithms except this one at the very top. So if we hit calculate, see all the different algorithms and the hashes that are generated, right? And again, up to 13 at one time. That's amazing. So now I'm just going to select this one, right? And you can see the remaining algorithms, they disappear automatically. With HMAC, we can actually edit the key format to allow text string or hex string, as we can see here, right? And we're going to use the default settings for this one. So let's do tidy mind, right? And then we're still going to keep the welcome here, right? Then we're going to click calculate, and it gives us all of these wonderful hashes here. So these hashes were made with a specific key entered, and usually this will be a secret key, right? Now we're just going to change the format to hex, right? And actually, you know what? We can actually deselect this. And then calculate. Now this is the same issue I ran into before. Last time we did this. So there it is. It had to be an even value, but that's fine. But this, at least if I were to give it a few more zeros, it would be the hex value for the color blue. Don't ask me how I know that. But finally, we load a file, right, to hashcack to be evaluated from the data format, and we can actually do file here. So we can actually do that. We can find a file, right? Then it should be in download. Let's see, download. Then we have nmap. Then open, right? Now notice that the path of the file is now populated, right, in the data text box. Let's calculate that. So it's gonna take a while because it's a path. It's not just a normal, just regular one file. All right. Still, the hashing is now displayed for the path, not just the particular file that we wanted to locate as far as the nmap, but the entire path is actually hashed, right? So it's MD5.1.256, things of that nature, right? Wonderful stuff, right? So now we can actually get into steganography, which I'm actually going to do a deeper dive on top of this exercise that we're doing in this video. I'm going to do it in a completely other video later on about stenography, right? So what stenography is just the process of hiding or covering a file inside of another file, right? It's mainly intended to hide a secret message in a plain message or a graphics file. So not new technology or anything. Has been around for thousands of years, of course. Was used by Greeks and Romans. And in recent times, the methods of stenography have, of course, changed, but the intent remains the same, right? So a basic stenography tool just encodes information within another file, as I mentioned, typically a media file in this case, like a picture, audio, video file. So a typical technique to encode this information, right, at least in the least significant bit of the image, like a video, audio data, right? It doesn't materially affect the file itself, at least like when it comes to video or picture or sound or stuff like that. It doesn't alter the file header, though it can change the file size itself. So what we're going to do first is hide documents in a graphic. This is going to be fun. So without prior context, it is extremely difficult to detect stenography, right? So what we're going to do is we're going to hide the contents of a folder in a graphic file. And there are various tools that we can use. One such tool is Gargoyle Investor, Forensic Pro, and we can actually perform the same task with a simple compression program like WinZip or WinRAR or 7-Zip. But this is gonna we're actually gonna use 7-Zip actually, for folder stenography. So actually, we can do it on this server. I was going to swivel over, but we can actually do it here. So let's actually open this up. And of course, the local, everything is on the local, right? And that's fine. Actually, you know what? Just never done it that way. I've always, I'd rather keep doing it with the right click. But let's get inside here, right? And of course, the folder is empty, right? So we need to create two new files, right? So I'm just going to create a text file really quick. And I'm going to do another. Perfect. So now they're both created. So just going to select both of them, right? And 7-zip. Then, of course, we're just going to add to this zip here. All right, so now we can see the zip has been created with these two files in mind. Now I'm going to need a graphic file that I need to copy to this folder, right? So for the sake of this lab, graphics file is already it's already been downloaded from Google. So we can actually download any graphic file of our choice, right? As far as real world scenarios, into our folder here. So for this demonstration, I already have a graphic file. Uh, yep, there it is. I'm gonna move it instead of perfect. So let's actually open up, right? Mm, actually, no, it should be because I ran it out the administrator. Come on, Win10, don't do me like this, buddy. Or is it the Wi-Fi? Huh. Okay. Uh, see. There we go. That's what we're supposed to be, right? So now we're just going to the copy. Okay, all right, perfect. So one file copy, so that means it's successfully executed. So now I'm just going to close this out and we're in the folder, right? And we see that it's new, right? It's literally the latest date, soonest date where we're at now. So it's definitely not the correct date and time, but this file is not the same as this file, even though they have the same type, right? So I'm going to double click here. You know what? Let me just do this here. Right, and I'm actually going to compare them. So do that here, and I'll actually do this. Let's see if I can go to the There we go. All right. Hey, new guy. What's up, man? Okay. So there, there. Go zoom on in. All right. Well, let me go any further. Let's see if we zoom. Well, I'm nearly halfway. So there. So they're literally the exact same. The exact same. All right. So just wanted to showcase that. Now I'm just going to close all these out. All right. So now in here, I'm just going to type for perfect. So now we have the window up here. So I'm just going to navigate to there we go. We got. All right. So we see both text files are displayed, right? So now I'm just going to use stag hide to actually hide the data in the image. So stag hide is a tool that needs to be installed on a Linux system, like Kali Linux. This is what I have at the bottom here. Now it can hide data in an image or an audio file, right? So it also can encrypt the embedded data in an image or audio file, which can generate the output to JPEG, PNG, BMP, WAV, OU file. So, in order to do this, as I mentioned, I'll need Kali Linux. So I'm just going to put it here. Right? Take the moment. I like it. Right? Perfect. What we want. Efficient. Perfect. All right. So perfect. All right. So now the stack hide install has begun. Should take a few minutes to complete. Right. Perfect. So the it's officially installed, and I'm just gonna. I like to work with a clean window. So I'm gonna clear this out, and let's actually take a look at this. Hi. Let's give her a hello. Perfect. Hey, Stack. How you doing? All right. So the help parameter that I placed in the command, right? It just displays the list of parameters that could be used with the stack hide command, right? So again, like working with the clear windows. So we're going to navigate inside the practice lab directory. So we're do that here. No, that's one. That's not possible. Let's see. Can't be right. Let's fix this. All right. So we're back on track. So now we're in the directory for the practice lab. So now we can actually create a little something here. The secret text file. Perfect. So again, like clean screen. So let's see the JPG. So now that we see also that the secret text file is not present in that directory, so now we can hide the secret text file in the JPEG. And so we can do this with this command. Now, before I do anything, right, I want to point out a few things. So there's two parameters being used, right? So EF, right here, right, is for the file that's being embedded. And then CF, right here, is for the file that will contain the embedded file. So With that being said, I'm just going to hit enter. And then, of course, it wants passphrase. So just enter here. Perfect. And now it's completely done. So, all right, so it lets us know that everything is taken care of. Let's go ahead and clean it up. Now, for users, of course, a JPEG file is a normal graphic file. So, however, we know that it has a hidden file inside. So to extract the hidden file, we can actually do something else. See. Instead of embed, we're going to extract, of course. Yes, of course. There it is. Okay. So now that everything is verified, right? The file extracted. So since the secret text file already exists, that's why I was prompted to overwrite the file. Got slightly confused for a second, but in a real world scenario, this is unlikely to happen. That I'll be extracting the embedded file in the same directory. So, but it has been extracted successfully, so we're good there. And we're good for being at the end of the video. Again, for a brief recap, this is the cryptographic basic concepts. And just for a brief recap of the things we went over. Went over just knowing cryptographic concepts, implementing cryptography, and using some steganography as we did in our last exercise. So went over a few things like key length hashing, different types of hashes using hash calc, right? Key values using crypto demos and applications. And this is actually going to be the last video for this particular series for part 2. We're going to have some more videos that will be uploaded for more advanced levels of cybersecurity. I hope to see you there as well. Stay curious, stay secure.